My name is Joseph Tadaro, and this is my physics video blog for Instructor Donald Johnson and the Fundamentals of Physics class. Well, physics and video game design. I suppose there's a finite variety of uses and applications of physics as it relates to my major. The focus of my video blog presented here is Newton's laws. Newton's laws have many strong ties both directly and metaphorically to video game design from many different aspects. Newton's first law, for example: as long as no unbalanced force is applied, an object at rest will indefinitely stay at rest. An object in motion will stay in motion so long as it maintains a straight line and keeps a constant speed. As far as the demonstration goes, I have here a small dice game from Steve Jackson's games, Zombie Dice. I figure this would serve our purpose as well. Now, once these dice have settled, they're unmoving. With no opposing force to push them into moving, they simply stay as they are. Now, as I rolled them, they fell prey to various forces such as friction and gravity, which acted against their momentum, forcing them to stop. From a game designer standpoint, the first of Newton's laws forms the basis for everything that happens in a game or a virtual environment in general. The avatar of that player creates stands triumphantly in the easterly breeze. His hair, his cloak, and his banner sail in the air currents as programmed by the physics engine. Now, that bullet that was fired from the sniper's rifle up in the tree is subjected to drop caused by gravity, wind resistance. The impact of that bullet causes our would-be hero and the ensuing dramatic fall to occur in sequence, and then his final roll down the hill, all implemented by an incredibly complex physics engine put into place by these principles. Now, Newton's second law: an object's acceleration is proportional to the force that's applied to it, and the force to accelerate an object is proportional to the object's mass. In simple form, Newton's law can be described as force equals mass times acceleration. While not directly related so much to the area of game design as the other two of Newton's laws I'll be talking about, this law is the basis for how laws 1 and 3 operate. As I push these dice, and they're falling prey to my force and moving around in kind, the harder I throw them, typically the farther they go, unless acted on an outside force like a wall or in this case my hand. And the more force I apply to them, the faster they go. Now, Newton's third law: for every action, there's an equal and opposite reaction. This is the very fundamental principle of what it means to make a video game. The player takes an action, regardless of the type of game or action made. The game then processes a reaction based on the player's actions. The player then reacts to the game's decision, and it becomes a perfectly balanced dance between man and machine until either by fate or design, one falters and the game is over, win or lose. This presentation was actually sort of trying for me to develop, I think mostly because I wasn't exactly sure on which scientific concept I was going to be best suited to explain here, but I hope this was enjoyable or at least somewhat informative for you. I know it was for me. I feel as though I've learned a great deal about the connection of concepts of physics in a game design venue, and all that in the short amount of time it took me to get this blog post out of here. Well, thank you very much. Have a good night.